Hello,
Uh,
how are you?
how are you?
I'm good. How about you?
Good. Sorry, I was actually tutoring.
Oh no, that's fine. I thought it's my it's from my like my time, and I did not see the calendar actually. I did not get that invitation, the Zoom one.
Oh, you don't?
Yes, so that is the thing. Just because I remember I asked you for a weekend class, but I did not find that actually.
Um, I thought I
Okay,
saw
like
you.
okay, one of my friend, he found corona positive.
You got corona?
Mm-hmm.
Oh no.
Now he's like going to be, he's at his home and now it's quarantine. So I was like, it's like this virus is like airborne. So just be very careful because your family can get it easily, right?
Yeah.
No, that's why.
Well, my roommate went to play volleyball on Monday, and apparently someone who played volleyball with her tested positive just yesterday. So she told me about it. So I'm trying to find a clinic where I can go and get tested, and they're all closed and they're all super booked
So
until next
did she go or
Tuesday.
no?
Huh?
Did she go for a test or no?
So I told her to go get tested. She said, well, it takes like 48 to 72 hours to manifest in the body. So she wants to wait until her friends test positive or negative, and then she'll go get tested.
Yeah, but just make sure like if you're in a same house, so just wear mask or spray
I
that
mean,
Lysol spray.
I'm beyond upset.
Are you guys using same restroom or you guys
No,
both? Then it's
separate
fine.
restrooms, just a kitchen.
Oh yeah, just make sure like everything should be clean or
Yeah, so
that.
I bought Lysol, like the spray,
Yeah,
rock spray. They were selling it yesterday at Costco, so I got some, and my friends got some. I'm pissed because I only have two friends that come over, and they don't even come over. They just like stop by in front of the door, and then they walk,
yeah, right. You told me. Yeah.
you know? But this one, I don't know.
I hate Costco. Today I went to Costco. I put like some stuff on my cart, and I went for a billing, and I waited like for 10 minutes, and when I made the payments, that guy was like, "Ma'am, we only accept Visa card."
Yeah, they only accept stuff.
I was like, what the like hell is this? Like you I said it's a MasterCard because I know like some most of the like stores they don't accept like American Express and Discovery. I know about that. But I was like, it's a MasterCard. He was like, no. I was like, okay. Then I had to left all the stuff. Came back. I was like, my time like got wasted.
Oh my god, that sucks. I'm so sorry. Yeah,
Why you why you sorry?
no,
I really don't understand like what the concept of like only Visa. You guys can take Apple Pay or no, they don't take that. It's like we take only City, I think City approved Costco card or something like that.
yeah.
That I like okay, let it be. I'll
Like about 10 years ago, they only accepted American Express.
oh really?
Yeah, they only accepted American Express about 10 years ago, and now it's just Visa, no American Express. So I think it's just about like who they are partnering up with.
Exactly right. Because I heard like the with the American Express, I think they give some good deals, or I don't know. Like,
I don't
most
know.
of the people, like most of the store, I have noticed like they don't accept Discover and American Express. I
Yeah.
don't know the reason, but they do.
Babita, I started looking into jobs.
Oh, congratulations!
Oh my god, I am not competent to graduate.
Why?
I don't know, Babita.
Oh, you will get a good job. Don't worry. California, like they lack doctors. You will get easily.
Not dentists. There's too many. It's oversaturated.
Oh, well, don't worry about it. You will get something over there for sure.
Oh,
California is a like hub of like most of the population is there. There are a lot of opportunities.
we'll see. We will see. Anyways, let's talk about buffers. Did you memorize strong acids, strong bases?
No, not yet.
Oh my gosh, Babita, I asked you one thing.
Oh, I'm not giving my exam in December for sure. No,
You're not?
no,
When are you
because
taking it?
I'll postpone because I want to take admission in 2022. So that's why. So I'll be taking my DAT. And the thing is that I want to prepare very well for that. So I don't want to take any risk because I was reading the comments on the Facebook. There are some people like they are retaking that test, and the duration is like you have to retake that test within a 90 days, like within a 3 months. So
No,
I don't
you
want
have
to.
to take it within 90 days.
No, like a lot of people commented on that, especially the dentists in that group. They said like within a you have a window of 90 days to retake that. I mean to take the second test.
Who says that? It took me through 2 years to take the second one.
I don't know. Maybe because for those students who wanna like for example, if someone gave test in February, right, and that person didn't score well, and he want to give the again so that he can get the admission for the upcoming year. I don't know. Like maybe that's what the conversation
But
was
you
going
take
on.
it once. Don't think about taking it twice.
Exactly. That's my point is. So I want to take one time and I want to give my 100%. So I do have enough time. So I just want to make sure before go to my test, I have to complete my this orgomen like chemistry one and the general one.
Okay.
I have to eat that book.
Yes. Yes. Yes.
So
Okay.
I was asking. So should I? I'm thinking to reschedule it for February end or first week of March. That's what I'm planning.
That's up to you.
What do you think? Because the thing is that once I will get my DAT score, the application will be open in May. That's the thing.
Yeah.
So how the universities will get my score? They will get it automatically?
No, they don't get it automatically. You have to send it.
So when I will log into my ASDA
Access.
application,
Yeah.
so my DAT score will be there, right? And I can send it to them directly.
Yeah, you send it through that, and you also have to send it through the DAT website. DAT website has a dent pin,
Uh-huh.
your dent pin, and when you are applying, when you register for the DAT,
Okay.
just click on all schools.
Okay.
Click all schools. That way, like, it gets sent to whatever school you want to. Otherwise, you have to pay extra fee.
Yeah, but for I have already like selected all the East Coast schools.
See if you can go back and reselect certain schools.
But like I did not fill the app. Okay, so right now my half application is done. So what should I do right now? Should I delete everything?
It will get deleted automatically.
Okay, so I don't need to worry because when I was booking for my DAT exam, that in that application I selected all the East Coast schools. So I think it was around 40 or 45. I think so.
Yeah, I
So
selected
I don't.
everything.
Sorry.
I selected all schools.
But I don't think so. Now when I will reschedule it, the that thing will remain same actually because
I think so. Yeah.
because rescheduling is done through Prometric thing. Prometric. I just need to go prometric.com. I don't need to
Yeah,
go
yeah,
that.
yeah. No, I understand. It's okay. You
That
should apply to my school.
can I add it later on because I have
You
seen like
can,
students are
but
adding later on.
you can add it later, but there's going to be a fee.
How much?
I don't know. I think it's like 45 or something like that, just to send the
Oh,
AT score. Just
okay,
to send the AT score.
yeah, that's fine. No, that's not a problem.
Oh, Babita.
No, but the thing is that like uh, what I was saying. So if I'll send the DAT score to them, but the application is going to be the same, right? I don't need to send separate application to your school, right?
Yeah. You're fine. Don't worry too much. Wait, did you come in contact with your friend who had COVID?
Oh no, he's not here.
Oh.
No.
Oh man.
He just called me and
Buffers today.
I said good luck. That's all I can say. And I say start drinking ginger, turmeric, cinnamon tea.
Ginger turmeric cinnamon tea. Oh goodness. Oh, I'm so pissed. My mom was so mad. My mom was so angry. She was like,
Why?
because she was telling me because I didn't tell my roommate to be careful enough. But it's not my fault.
She is careless. What you can do? You can't do anything, right? If
Yeah.
she's careless. So
I don't know.
doesn't this.
I told her, can you please stay in your room and not come out until we find the results? And she's like, it's not like I come out anyways. I'm like,
You know, just do two things. Just wear your mask if you're going in a kitchen and just drink cinnamon, ginger, turmeric tea. You will be fine.
cinnamon ginger turmeric tea. Yes, ma'am.
Yes. Just boil it before go to sleep. Just drink 1 cup, and in the morning you will be so good.
Yeah, my friends were really upset too because they're super careful and they trusted me to come over to my house because they don't go anywhere. And for my roommate to be exposed, like that's BS. So,
Even I don't go anywhere because
I don't go anywhere.
I don't go anywhere. If I go outside, I wear 2 masks. So
Me too. Two masks and a face shield.
not the face shield, but yeah, the face mask. And I always carry that spray sanitizer. So I spray nearby like this.
Oh my god. Anyways, okay, buffers. This is like a sponge, okay? It's a solution that absorbs extra protons or hydroxides to prevent drastic pH changes. Okay, so this is made with weak acid and its conjugate base, or weak base conjugate acid. Okay. So think of it like this. HF, is this weak or strong?
It's strong.
Oh my God, Babita. It's weak.
Strong, weak acid.
It's weak acid. I told you. Please memorize.
Oh no, in my mind that electronegativity is going on. Fluorine. So that's why it's a weak acid.
Yeah.
So
Okay. So this is a weak acid. And what happens is you put in a strong base like NaOH. And let's just say you only put 3 of them. Like this. Okay. When that happens, this happens. And now you only have 1, 2, 3 F minuses. Okay. And you have 1, 2, 3 HFs. This is the best buffering capacity because you can now put in acids or bases and it'll all get absorbed.
because it is balanced, it's in the equilibrium, that's why.
Good, yes. Okay. So usually the way this happens, they will tell you the Ka value of HF. And let's just say this is like 2.3 times 10 to the negative 4, okay? Let's just say you started out with 6 molarity of HF and you added 3 molarity of NaOH, okay? And they ask you, find pH, okay? So, and let's just say all this, it's like, this is like 1 liter and 1 liter, okay? So the first thing you do is HF plus OH minus is going to be
H2,
HF minus plus H2,
H, right.
okay? You need to find moles of each. So this means you have 6 moles of HF and you have 3 moles of OH minus. All 3 moles of OH minuses will be used up, creating 3 moles of HF. Okay.
Just a second. So the ratio is over here. So we have 6 mole of HF and 3 mole of OH. Understood. So this 3 mole, this one below 6 mole, how come? Is it stoichiometry?
This is stoichiometry, yes.
Okay, so it's the ratio is going to be if we see 2:1, right? If we see.
Yes. So now we have 3 moles of HF, 0 moles of OH minus, and 3 moles of F minus, right? Now, from here, what you have to do is you have to divide it by the total volume, which is 2 liters. 1.5 molarity of HF and 1.5 molarity of F minus. Okay.
So 2 liter, why did you, okay, okay, got it. Okay.
Now that you have this, we need to figure out how much HF will ionize on its own because it has a Ka value. So we have 1.5 molarity and 1.5 molarity, but 0 HFs. X amount will ionize, adding X amounts of each, right? These are negligible, and that's that. Your Ka, it's H plus over F minus over HF.
It's going to be 1.5 upon 1.5. It's going to be 1 then. X 1.x.
Right? And we
X.
2.3 times 10 to the negative 4.
How did you get this one?
Oh, it was given up here.
Okay, oh, sorry. Okay.
Okay, so this is H plus concentration, right? And now all you have to do is plug it into your pH value, negative log of
So
H.
2.3.
So this is basically saying after you put in the base, what is the pH? And it's like 3.6. That's your answer.
Can you explain the second step, like this HF gives H plus ion, F negative? How, like,
Yes?
yeah, the second step. Yeah, I didn't
Yes.
get that.
Okay. So at first you ionize by this, right? You're trying to find the new concentration of HF and F minus, right?
Right.
Okay. With the new concentration of HF and F minus, okay, what you're going to do is you are trying to find out how much of HF,
Bless you.
thank you, how much of HF splits, okay, how much of HF splits as natural, okay, creating H plus concentrations.
Yeah, right.
Okay, and that is based on the Ka value. Because
So,
this number and this number is not at equilibrium right now.
Right. But we do have a value of HF, and we want to know how much is the value of H
H
plus.
plus. Yes.
So what you have done below this point, 1 point F, X,
So
0,
then I am looking for H plus concentration.
Okay, understood.
Yeah, okay. Good. All right, so this is step 2, right? Okay. So this step 2 can actually be done in a simpler way. The simpler way is by this thing called the Henderson-Hasselbalch equation. Okay. So the Henderson-Hasselbalch equation is pH is equal to pKa plus log of conjugate base over acid. Okay. So pKa is negative log of Ka, right, plus log of F minus over HF. This is negative log of 2.3 times 10 to the negative 4 plus log of
F negative.
5 over 1.5, right? Okay. So you end up with 3.63. Does that make sense? Okay. So this equation you should memorize. Cookies. Yeah. Okay. All right. So let's talk about this again. Okay. So I am going to put, I started out with a weak acid. I am going to put in, and it looks like this, right? This is called equivalence point, remember? The equivalence point is when H plus concentration equals OH minus
OH negative.
Okay. And let's just say that this is like 20 milliliters. Then this is 10 milliliters. Okay. So 10 milliliters, this is called mid-equivalence. Mid-equivalence is when HA concentration equals A minus concentration. This right now is mid-equivalence.
Yeah, because they are equal.
Correct. So we have 1, 2, 3 F minuses and 1, 2, 3 HFs. When the two are equal to each other, pH equals pKa. Because look at this, of this equation.
Right.
Okay. All right. So this right here, plus or minus 1 pH, this is the best
For
buffering capacity.
basically when HA equal to A negative, right?
Yes. Good. And then this right here is called the end point. This is where indicator color changes.
Which basically tells like, is it acidic or base, right? That in color
Yes.
change.
So after you're done with this, you have an indicator. And the indicator is a very, 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 very weak acid, right? It's this, right? So if there's an extra OH minus, it'll pair with the indicator, right? Leaving ion minus around. Okay. So do you want to do one practice for this? Just give me one moment. All my friends are freaking out. They're like so mad.
For this thing.
Doesn't care. So irresponsible. I think this is too easy for you.
Till the moment, can you scroll down? I will write the formula.
This one?
Yeah, we are doing problem on this one, right?
Yes. Turmeric, ginger, cinnamon tea. Isn't that the golden tea?
Oh, that's my tea.
That's
My formula.
That's Babita's tea. No one else's, just Babita's. I actually had cinnamon tea today.
You can add some black pepper if you want.
Black pepper? That's spicy.
No, but it's good. Little bit you can add it if you want. Little bit.
A little bit.
Yeah.
I pepper on soup, so that's okay. All right, Babita.
Your 14.85 gram sample of the weak ethylamine is dissolved in distilled water to make 500 ml of solution. Calculate the molar concentration of the C2 in the solution. The aqueous ethylamine. Okay. So for I can do first B. So it will be because we have to write that equilibrium constant.
Here you just have to do.
Yeah, for second question, it will be like so when we say equilibrium constant, we write Kp, right?
Correct. For this one,
Okay.
Kp.
Yeah. So sorry.
What about for A?
Oh yeah. For the molar concentration.
And I'm just lazy, so I'm not going to write all the subscripts.
Yeah, that's fine. Okay, so appears until so we have a formula for that to find it. Let me write the formula, please. Okay. So Kp is equal to CDH5NH3 plus OH negative on C2H5NH2. Okay, so we have C2H5. So we have given different, so we have given Thailand, so we have given 14.85 of that plus RT. So for the molar concentration, we are going to use the formula like mass into volume. So we have already given mass 14.85 into 500 ml of solution. Is that correct?
Yes.
So we can convert that divided by 1,000, right? We have to make it in
First, you
the
have to find moles.
okay.
5 moles.
So just a second. Can you tell me the molecular mass of nitrogen?
14.
Good. And carbon is 12, right?
Carbon is 12.
So it's going to be 0.28 moles.
45 here.
Yes. So it's going to be 0. It's not going to be 45. It's going to be 14.85. Then the total is 53. 12 into 2, 24 plus 5, 28, right? 24
45.
plus, yes. Oh no. So what I'm saying is C2H5 and H2. So it's going to be 24 plus 5 plus. So it's going- how you are getting 45? I'm getting 57 actually. The molecular mass, we are adding the C2H5NH2, yeah, plus 5 plus 28.
Why 28? There's only
Oh,
one.
oh, right. 14 plus 2. Sorry. My mistake. Sorry. 0. Yeah, you're right. 0.329. Then we have to find the molarity.
Yeah.
So it's going to be the same, right? The formula of molarity.
Yes.
Mass into volume.
And this divided by
1,000.
the volume.
It's going to be 500 into multiply by 1,000 because yeah, same thing. Right. Okay, so the next question is of C2H5 aqueous, okay, which is present in the solution at higher concentration at equilibrium, justify your answer. Okay, so C2H5 was there. That means so it will go towards the product side.
Yes.
Okay, so the next question D. A different solution is made by mixing 500 ml of molarity with 5. Okay. Assume that the volumes are additive. Okay, the pH of it is found to be zero. Calculate the concentration of OH negative in the aqueous form. It's going to be, so we are going that Henderson one formula use, right? The pH is equal
You
to,
could, but you don't have to,
why?
because there's an easier way. Read it. You didn't read this part.
No, I read it. So it's saying the calculate the concentration of OH negative in the aqueous solution. So we already have pH given 500.
So if they want just OH minus and you have pH, you can do this.
pH is so we are not going to use the same formula that Ka plus log of A negative Ha1.
You don't have to use Henderson-Hasselbalch.
So pH is basically equal to minus log of H plus then that formula. Oh, hold on. Hold on. So it's 4.93.
So POH,
Yes, 4.93. Yes, this formula.
it's 3.07, right?
No, 14 minus 10 point. Oh, right. Yeah, it's 3.07.
Yeah, that's POH. What is OH minus?
Okay, so OH minus will be 10.9. Okay, so oh, that's the value of POH. Okay, POH is equal to minus log of OH negative. So 3.07.
Yep.
What have you done?
Because POH equals 3.07, right?
Yes, and yeah, and we have to find the OH negative, right? So,
Yeah.
so for that we have to find. So we have to put the value in a formula is H plus OH negative equal to 1 into 10 raised to the power minus 14, right?
Yeah. No. POH is 3.07. So 10 to the negative 3.07 is OH minus concentration.
Yes. But the formula I have, I'm seeing that one actually. You taught me one that H plus OH negative equal to 1 into 10 raised to the power minus 14, which is equal to KW.
Oh yeah, you can do it like that too.
So let me do in that way. H plus.
But for that, you need pH become H plus. And what that's 10
So
to
how you
negative.
have done this one?
So you have to find H plus concentration. And then plug it in there. This goes in here.
No, I'm asking how did you get this 8.5 into 10 raised to the power minus 4 molarity?
Oh, because I did pH plus
Mhm.
pH equals 14, right? And we found it was 3.07.
Yes. Right.
POH is 3.07, right?
Right.
But POH is negative log of this.
Okay.
So if I want just OH minus, I have to raise it to the 10. Get rid of log.
Okay. So 10 into 3.01, that's what you have done, right?
Yeah.
So 10, okay, minus 3. So you put 10 raised to power minus 3.01. Am I getting you right?
Yes. 3.07, negative 3.07.
So after that, how did you get this value? 8.5 into 10 raised to
If
power
you
minus.
put this is this,
Huh?
it's the same value.
How? That's what I want to know.
Just put it into the calculator. It gives you that.
So basically, if so, it will be 10 raised to power 3.07. No, I'm not getting this value 8.5 anyhow.
10 to the negative 3.07.
Can, can you simplify? Can you simplify me here? How you? No, not the calculator one. How you are simplifying this equation?
I'm not simplifying this equation. I am just saying POH is negative log of OH minus. POH is
Right.
0.07.
Right. 8.0.
I have to raise
Okay.
it to this. Then log disappears to make OH minus.
So can I leave it like this instead of simplifying that?
No, because you really can't raise anything to a decimal.
Yeah, and after that, like, because I in my this calculator, I can't see this kind of option, like where 10 I can get the value of this one.
You can do 10 and then caret. What kind of calculator do you have?
Oh, I'm using my phone. That's why. That's all.
Oh, Babita.
Okay,
Okay.
so I will use it.
Okay.
How did you use in the calculator? I'll buy the calculator.
10
Uh-huh.
and then caret negative 3.07. And then
Oh, that's the thing. Okay, so the next question is calculate the concentration, molar concentration of, okay, that is formed in the reaction. So we have to find the molar concentration.
you need to find the equation first.
The equation will be C2H5NH3 plus H2O equal to CO2 plus H2O plus NH3. Am I right?
No.
CO2 plus NH3, H2O.
Because it's HCl. You are adding HCl.
Oh, okay. Write the net ionic C2H5. I jumped into third question.
That's why I said you need the equation.
Okay. If we have to find the molar concentration, So it's going to be the molar concentration. So when we say molar concentration, it's the same thing, right? We have to find the moles.
Yes.
So is it going to be the same? No, it's not going to be the same. NH3 plus. Is it 22.5?
So we have to find moles first, right?
Yeah, so moles will be. Can you tell me what is the difference between moles and molar concentration?
Molar concentration is molarity. It's moles per liter. Moles is the actual like head count.
So, so we don't have mass actually. If we have to find the moles, we need mass upon molecular mass. We do have
No,
molecular.
no. We have volume and molarity. Volume and molarity. Remember, if you multiply these two, you get moles.
That's what I did. So I got 22.5.
22. Is it 0.25?
So moles, molar concentration is equal to. It's divided by 1000. 0.25. Okay.
Why is it 0.25?
0.25. Yeah. Mhm. Yep. So what is the value of Kb for C2H5 and H3?
Oh no, this is different.
Yeah, I don't know why you're doing this one.
This is 0.1. So you end up with 0.15 molarity.
Why you are doing this when we have already found the moles
Of what?
of this one C25 C2H5 and H3 plus?
We don't have moles.
So so we find the mole of what then?
So this is how you started out with this. You
Right.
add acid, right? When you add acid, you make extra conjugate acid. So your concentration of the base and the conjugate acid changes.
So,
Let's just say you have this, okay? And you just added acid. Right? What happened to your concentration of NH2? It changed.
right.
Changed. Your H plus disappeared, right? So it's 0. But what did you do? You created one, 2, right? Or 0.1 of NH3s. Now that you have this and this, you can put it into the Henderson-Hasselbalch equation.
Why did you put 0.1 molarity below 0.25 molarity?
Because you had 0.25 that you started with, but the acid was limiting. So this is stoichiometry by taking out acid.
Basically, we have to cancel that out, right?
Yeah.
So now pH equal to, but why do I need to put in that Henderson rule?
You can put it in the Henderson to get the pH.
Who said to find the pH?
If you want to find the pH.
Okay, so for pH, we need a Ka plus log of A negative Ha. So we don't have Ka.
This is actually Kb.
Are you doing third or fourth?
I'm just saying, for the Henderson-Hasselbalch, you need Kb. It's like this.
So the Ka, okay, so the pH equal to Ka plus log A negative, that's a different formula, and this is a different formula?
Yeah, for pH is different than pOH, right? It's the opposite. Right?
So we have POH.
But if they want you to find Kb, okay, if they want you to find Kb, how do you find Kb?
We just put the value what we have given.
Well, you need the formula. You need the equation. Right? And we found out that this is what 0.15 here, 0.1 here. And remember for OH minus, we found it up there, 10 to negative 3.07.
Right.
Now you can plug this in. Like that. And find Kb. Does that make sense?
Sure. Understood.
Yeah? Okay. Okay. Does this kind of make sense?
Yes.
Okay, Babita. There's actually there's a very good practice quiz testingy that one of my students sent me. Give me a second.
On this topic, the acid-base one?
Yeah. And I want to share it with you, but it won't. I don't remember which one it was. I think it's this one.
You know what? We have got snow yesterday.
You got snow already?
Yep.
No, you did not.
I did. I'll share the video.
That is crazy.
Minnesota is crazy.
Oh my God, I cannot
Minnesota is.
snow already. That's awful.
I know. Super crazy.
That is. That's crazy. That's outrageous. Okay, so here are extra explanations for you that I will just print out for you and send it to you.
Okay.
But yeah, so anyways, let's try doing question number 2.
Calculate the volume required to reach the equivalent point, the pH after adding 5 ml of KOH. Okay, and the pH at the half equivalence point. So 40 ml of 40 ml solution. How do we write nitrous HNO3?
Yes. No, HNO2.
Plus, so it's titrated with KOH, right? So what exactly we get? So we have to write the equation first, like HNO2 plus KOH, right?
Yes, but remember K, it can disappear.
So it's going to be H2O plus NO2 negative, NO3 negative,
NO2 negative.
plus H2O, right?
Yes.
So what we have to question 2. So we have to calculate the volume required, okay, to reach the equivalence point. So we have 40 ml of solution of 0. Okay. Fine. With 2. So we have the molarity is given like 0.100 and what do we have? Oh, I'm doing, wait. So as per that stoichiometry, it will be 80. The volume, if we have 0.1 molarity, we are getting 0. Sorry, it's It's 40 ml. So we have so index the X will be 80 ml. I mean to say 0.08 ml, 0.08 L.
Yes. This is at equivalence.
Right.
Okay. All right. What about pH after adding 5 milliliters of KOH?
So basically we are adding hold on. So we are so basically we are increasing the volume by adding more KOH, right? OH negative. Okay, let me see. pH after adding 5 ml of K. pH after adding 5 ml of KOH. Why 0.05? Did you 0.080 0.08 plus yeah. How did you get that 0.05?
They added 5 milliliters.
Yes, in the same solution. So we are adding basically 0.08 plus 5 ml, 0.05 liter, right? Vicky?
So if you multiply these two out, you're supposed to get moles, right? This is just
Okay.
step one.
No, my question is, how did you get 0.005? So did you add 5 ml with 0.08?
Oh,
So basically we are doing it separately, right?
yeah.
Okay, 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 understood. Okay, got it.
Because you at first you have to find moles.
So, okay. So it will be 0.001 mole, right?
Yeah. You have to find moles.
Moles is already there, 0.004 mole.
Right? And then from here, you have to divide it by the total volume.
Total volume will be 5 plus 0.20. So this is the answer, right? 0.22 m.
Yes. But remember, this is that of HNO2 and NO2 minus, right? And then what do you do to find pH?
That product upon reactant, that thing, same thing. So many formulas. pH is equal to minus log of H plus, or POH is equal to minus log of OH negative.
Hold on.
So pH equal to 14 minus POH.
Yeah, but you need the pKa, right?
This is very confusing. When we have to use this formula, when we have to use that.
It's when you have concentrations of acid and conjugate base.
Have K value. Do we have value of pKa? No. So we have both, like 0.22. Okay, fine. So we have to find the pH, right? So what's the value of pKa then? How can you find the value of pKa?
pKa, they have to tell you the pKa.
Do we have pKa?
No. Let's just assume pKa is like, let's just assume Ka is 2 times 10 to the negative 4.
And how you remove the log actually into 10 raised to power?
You just have to do negative log of 2 times 10 to the negative 4.
So it will be, so if we do the calculation, so the value will be -2 into 10 raised to power -4 plus 0.022 divided by 0.066, something like that.
What do you mean?
No, so if we put the value over here, so it will be, so the way we will solve, it will be 2 into 10 raised to power -4 plus 0.022 divided by 0.066. That's how we will solve this problem.
Yes, like this.
So it will be 2.33 into 10 raised to power -4.
This is 1/3. Yeah, if you just assume this is Ka and that's just 1/3.
1/3 means, yeah, so the total answer will be 2.3 into 10 raised to power -4, right? That's the calculation I have done.
Negative 3.22 is what I got.
How did you do the calculation? Like -2 into 10 raised to power -4 plus 1/3? How did you get that? I don't know.
Because I put in negative log of 2 times 10 to the negative 4.
Can you help? Can you write it down, the simplification, how you are doing it? Because I'm not getting that step actually.
I just plugged it in into the calculator. I
Oh,
put this in and I added the two.
Yeah. So do we have like do we get the calculator there over there in the exam?
Yeah, you just put it in.
Because I don't know how to use that log calculator. That's all. And how you are going to show the value. So are you putting this real value in your calculator, like minus log of 2 into 10 raised to the power minus 4? That's what you are putting in the calculator directly?
Yes. Yes.
Then I have to learn how to do that. Okay, that's fine. Okay, fine.
Make sense?
Yes.
Okay. Um, let's see. All right. Let's do,
Are we done with the acid and base?
yes.
Okay.
Let's do electrochemistry.
Okay.
Okay. So do you remember doing redox?
Redox reaction, yes.
Yeah. Okay. Let's just talk about doing the galvanic cell and electrolytic cell. So galvanic cell is negative G. Do you remember what negative G meant?
Electrode or anode, something, cathode and anode? Cathode and anode?
Yes, but no, not that. What does negative G mean?
That energy is like releasing or absorbing?
No, it means spontaneous. What does spontaneous mean?
Fast, like
No, what does spontaneous mean?
kind of sudden reaction, the redox reaction?
No. What does spontaneous mean? Spontaneous means that it happens naturally without external forces, right?
Right.
So galvanic means no battery needed. Okay, so this is the cathode and anode cells. And inside it, we have metals. And let's just say we have copper and zinc.
Right.
And let's say this is a wire.
And then we have electrolyte solution or something?
So inside it, we have coppers and zinc. Okay, but we also have anions that are exactly the same types. Okay, now they have to give you a list, and on the list, it's going to have this copper. When it gains 2 electrons, its E cell is 0.34 voltages.
Right.
Okay. Zinc this. Okay. Now between the two, whichever one is more positive is going to undergo reduction. Which one is undergoing reduction?
0 point, this copper 2 plus.
Good. So this is undergoing reduction. This means that zinc
Oxidize?
is getting oxidized. So that means that I have to switch the signs and switch the arrow.
Will go under oxidation.
Okay. So then from here, okay. So from here, reduction is the one that's undergoing cathode. This is undergoing oxidation.
Anode.
This is an anode. Okay. So when we have oxidation, it means that we are losing electrons. So zinc is losing 2 electrons, and the wire is going to transport it over to copper. Okay. And so when this happens, the 2 electrons from copper are going to become copper atom, and the copper will start to gain in mass. Zinc will start to lose electrons and lose mass.
So it will become zinc. Okay. Mm-hmm.
And it becomes that.
Right.
Does that make sense? Okay.
Yes.
So copper is undergoing reduction, which is a cathode. Zinc is losing electrons, so it's undergoing oxidation, so it's an anode. Okay. Okay.
Right.
Okay. So that's it, basically, for this.
Galvanic cell, right?
So this is the galvanic cell, and now what you got to do is you find the E cell potential. So how much, every time electrons move back and forth, okay, you are producing some type of voltage, and the equation is this.
E cell equal to E is like the electrons, right?
E cell is E reduction plus E of oxidation.
Yeah. So what E implies? Like electrons or something, or just like that?
No, this is electrical potential.
Okay.
Yes. So
Can you write it down for me? E equal to electrical potential.
Oh, it's actually written as EMF. I don't exactly know what that means, but it's electrical potential.
Okay.
Okay.
So we have like 0.34 plus 0.76, right?
So the reduction would be 0.34 voltages, and the oxidation is
Minus.
positive 0.76.
Okay.
You put in the oxidation potential. Okay. And then all this to be equal to 1.1 voltages. Okay.
Okay. Got it.
So from here, delta G is equal to negative NFE. Okay, N is number of moles of electron.
Transferred, right?
Yeah, that goes back and forth. This is Faraday's constant,
Mm-hmm.
and it's 96,485 coulombs per mole of electron. And E is E cell. Okay. So for this, two electrons, Faraday's constant is 96,485 coulombs per mole of electron. And E is
1.1 volt. Yeah, right.
okay. This is still going to give you a negative number, which means delta G is spontaneous. Does that make sense? Okay. Now we have voltaic cell. Oh, not voltaic, electrolytic cell.
Electrolytic.
And this one needs battery. And this delta G is positive. This means that it is non-spontaneous. Okay. So for instance, I have silver and I have a fake jewelry.
What did you put in that? This vessel?
Fake jewelry. Okay. So if you look,
Ag2 plus. Okay.
this is 0.80 voltages. And fake jewelry becoming fake jewelry is 0 voltages. Okay. So here, the battery is doing the work where the silver is falling off.
Okay.
And the battery is stealing electrons, okay, and putting them there. And it will start gilding it when the silver comes over and starts getting plated over the jewelry. Does that make sense?
Yeah.
Okay. So here, this is losing electrons, so it's undergoing oxidation, which means that I am also switching the sign and switching the arrows, right?
Yeah, it's going to be
By
minus.
default, this is undergoing reduction. Okay. Now, again, if you put it, so, but then oxidation is still an anode, reduction is still
Cathode.
a cathode, right? So here in a galvanic cell,
Mm.
the cathode was positively charged, attracting electrons, and the anode was negatively charged, pushing electrons away. Right? But here, the silver is still an anode, so it's negatively charged, and the reduction is positively charged. Does that make sense? So the charges don't the charges are the only one that changes.
Mhm.
Oxidation anode. Oh no. Oh no, sorry. The charges are the only one that changes, making this positive and making
Right. So this will be 0.80, not minus, right?
no. The side of the cell. Like the cell is positive, not the numbers. The numbers are still the way they are.
Okay.
Yeah. Okay. Okay. But we got to do this.
That's the change, right? Delta G is equal to minus NF.
Yes. So this is still one electron, right? 96,485. And this is what? Negative number.
Yeah, that negative. Okay.
So what is delta G?
It will be positive.
Good?
Yep.
Good. Okay, that's it. Let's do some practice problems for this. Wait, there's one more thing actually. K is negative RT, oh, not K. E cell, no. Delta G is negative RT, ln of K. Okay. This is for electrochemistry delta G calculations when you have at equilibrium. When it is at standard, okay? But if it's not at standard, okay, it's ln of Q. Good. And the Q and the K, you can actually use the anode and the cathode concentrations.
So if it's minus RT, it will be the cathode, and if it's plus RT, it's going to be the anode, right?
Yeah.
Okay.
Good.
So I think so. So in the first equation, it will be the cathode, and in the second equation, it's going to be the anode, right?
So
How would I come to know? Like I put anode or cathode, like that.
you have to look at the equation. When we're balancing equations, you look at the equation, right? Like for instance, for this one, right? For this one, you would actually have to look at the equation here.
So in both the case, one is losing, one is gaining. Okay.
Yep. So it's Cu2 plus zinc
Equal to copper plus Zn2 plus. Okay.
So you would actually put this over this. These are solids.
So now what equation we are going to use for this one?
If it's at equilibrium, you use this. If it's not at equilibrium, you use this.
Can you give me the example of when it's not in the equilibrium, like any reaction can you show?
I don't have one right now, but I can look for one.
Okay. Well, next class I'll ask you.
Okay. I have to find it because
Okay.
they don't, yeah,
Oh no, it's fine. Take your time, no worry.
sorry.
No, that's fine.
But yeah, but that's what they're trying to say here. Does that make sense?
Yes.
Okay, cool. So next class, because we're done with chem.
Chemistry is done.
Yeah, I mean we have nuclear chem, which is, I think we did nuclear chem, didn't we, last time?
No, we were continuing with this thing, the acid base.
I think we did nuclear chem. Oh, I think we did it like equilibrium. We did equilibrium. Or maybe not. Or kinetics. Okay. Or here. I don't remember. Anyways, okay. I think we just have nuclear chem to do, and then maybe practice electrochemistry, and then we're done.
Okay.
So after that, we're doing organic chem.
Okay. Got it.
Okie dokies. Alright, Babita. I will send you the file and I will send you the recording.
I will let you know when I want the next class. Is that fine?
Yeah. Just let
If
me
you
know.
will have time, if you will have time, just let me know, or like we can like accommodate like that. Okay.
Okay, sounds good, Babita.
Okay. Bye. Take care.
Alright,
Good night.
bye.
Enjoy your weekend. Bye.
You too.